Okay, this is converting to standard form, part 2. And as you can see, I've got a function already on the board here, and what I want to do is take it from general form and try to work it to the more useful standard form. So what do you do when you got a number in front of the x squared? Because we didn't have that guy before. Well, what we do is we factor it out. Okay, so I'm going to factor that -2 out of there. Now, I can factor it out of the 8x as well. Now it's a -2, so I need -4x. But we don't factor it out of this guy, and it's not because it's a funny number and doesn't fit, but I'll show you what we do with all this. We just leave the -3 at the end. Okay? So if you look at this, if I expand this out, I still have my -2x squared and my positive 8x, and there's my -3. And you notice I left a little space. Okay, here's what we do. We sort of ignore the -2 for the moment. We look at the x squared and the -4x, and we complete the square. So to complete the square, I need to take half of -4. So that's -2. And I want to square that. And that's the number that I put in to complete the square. So that's +4. Now, we also have to compensate the fact that I just stuffed a number into my right side of the function. But the number that I stuffed in isn't actually 4. Because it's in the brackets, it's affected by this -2 that's out there. So the number I actually put in is -8. So I go, oh my goodness, I put -8 into the right side. How do I compensate that? Well, that means I'm going to have to add 8. So be very careful when you complete the square. It's affected by anything that you factored out that's out in front of the brackets. Okay, so now we carry on. We've got our -2 out in front. And I'm going to go ahead and factor what's in the brackets here. And of course it's cooked up to do that very nicely. It's an x. Now that's a -4x. I want minus. And then the number that I need here that's going to multiply by itself to make that 4 is the 2. So there it is, all factored. And then I combine -3 and +8, and I get +5. And that's all there is to it. So that's my first example. Not too bad. Of course, they can be a little more unpleasant, and that leads me to my second example. So here we go. We're going to start up high here because it's got quite a few steps in this one. So we're going to have a function of 5x squared plus 6x. So this one you look at and you go, oh boy. Oh, and no number tacked on. So I look at this and I go, well, he said if there's a number in front of x squared, I'm going to have to factor that number out. And you are correct. So we factor out the 5. That leaves us with x squared. So that was easy, but what do we do now? Okay, when the number isn't an obvious one to factor out, here's a little trick. What you do is build a fraction and you put a 5 on the bottom. And that's so that when you go 5 times this fraction, the 5 on the bottom cancels with the 5 out in front. And then you put what you want to end up with on the top. Okay? So if you build it as a little fraction with 5 on the bottom, it makes it pretty easy. So we go, okay, that's all nicely factored, and then I leave a little space because I'm going to complete the square. But now it's really an awkward number. How do I figure out what goes in here? So here's how we do it. Even though it's fractions, the method works. You take half of 6/5. So you go, well, how do you get half of that? Well, it's easy if you remember the word of translates in math as multiplication. So a half of 6/5 is no different than 1/2 times 6/5. So this is going to be 6 over 10, and I'm going to reduce it because I can divide the 2 into the 6, and so that's 3/5. Okay, and remember what we have to do, the number then gets squared. And that's how we complete the square. So we want to tack on a 9/25. Okay, so that's the number we got to tack on over here. So plus 9/25. So that completes the square, but now I got another mess to worry about. How do I compensate the number I just put in? So let's see. We got just enough room on the right side here that we can, no we won't. Okay, I'm gonna make some room over here, and then we'll just work in this zone over here. So I'm just gonna delete that. It's got a little bit more room to work with. So what do I need to compensate? Well, the number that I actually put in is 5 times, because we've got the 5 out here, 5 times 9/25. So it's not that bad. Okay, it looks a little ugly, but actually the number we put in is 9/5. So what I've done here is I've divided the 5 that's out in front with the 25 on the bottom. So to compensate, I'm just going to take away 9/5. All right, so now all I got to do is clean up the rest of this thing. Let's just separate that off. So we're going to go equals 5, and now we've got to put this in its factored form. So we know it's going to be x. And the way I usually do this, okay, here's a plus, so I know this will be a plus. And I usually just look at the number at the end here, and I ask myself, what times itself gives me 9/25? And so that would be 3/5. And then at the end I have minus 9/5. So not too bad, and this was the ugly one with fractions. So if somebody comes along and says, hey, where is that vertex? No problem. Okay, the number that makes this 0, -3/5. And if we plug that in, and it does make this all 0, which wipes out the whole first part of this, we're only going to be left with -9/5. So we go, yep, there it is. And if someone said maybe further, they said, I just really want to know where is the axis of symmetry. So where is that axis? Pretty easy, because it's always x equals wherever you're going, wherever your x coordinate is on the vertex. So we can just write that as x equals -3/5, and that is the axis of symmetry. And that concludes my look at converting to standard form. So I'm going to stop there, and we'll pick it up later with something else.